The EAR project, Ecuadorian Antarctic Refuge, listened to Antarctic nature to propose a shelter space for researchers during their expedition and to be able to test eco-materials such as bamboo, abaca, coconut tow, and rye husks, which in turn attribute the identity of the country to this small construction. I am Andrés Donoso, architect, director of the EAR project.
And I am Cesar Aguirre Cornejo, architect expeditionary who carry out the construction of the refuge.
And on behalf of the entire team, we will share the story of how we managed to make the idea of an ecomaterials refuge in Antarctica a reality. This project arises from the Faculty of Architecture and Design of the Universidad Católica de Santiago de Guayaquil, which has an ecomaterials factory in Durán, Guayas Province, Ecuador. In this factory, different types of natural fibers were tested, many of them considered waste, with thermal insulating characteristics that allow us to use them in the construction of the shelter. In 2016, a cooperation agreement was signed between the Instituto Antártico Ecuatoriano and the Universidad Católica in order to carry out scientific research using ecomaterials as thermal insulating elements. Tests were made in previous expeditions to demonstrate the behavior of fibers such as bamboo, banana raches, coconut tow, and abaca with the low Antarctic temperatures. The first prototype was built on the slope of the Chimborazo volcano under the direction of the architect Alejandro González, in which 100% of the tested ecomaterials were used. The second prototype presented a red metal structure as a supporting element for the ecomaterials panels, and it was exhibited in 2018 outside the faculty of the university, prior to its transfer to the facilities of the Instituto Oceanográfico y Antártico de la Armada. After seeing the second prototype, the Instituto Antártico Ecuatoriano requested certain adjustments to the architectural design. First, recover the impact created by the exposure of natural fiber, as was done in the first prototype, by means of a second external skin and reduce the visual proportion of the metallic structure. Second, improve anchoring to the ground to prevent the shelter from overturning in the face of hurricane winds from Antarctica. Third, add a binding element that holds together the organic waste of the eco-insulating materials to avoid affectation and contravention of the International Antarctic Treaty. Fourth, supply photovoltaic energy through solar panels. Fifth, add accessories for a better operation of the shelter, such as stairs, hatch, and observation chamber. The final approved prototype was inaugurated on February 19, 2019, in front of the Catholic University and Ecuadorian Antarctic authorities. Once the design with its adjustment was approved, the final construction plans were drawn up where all the aforementioned improvements are observed. Because the quota assigned to build this shelter in Antarctica was limited to a single expedition member, an EAR construction manual was prepared so that the people in charge of construction could visualize the entire construction process in detail. The construction schedule in Antarctica was drawn up, restricted to 11 days of construction due to the times available to the expedition before being picked up by the Chilean Navy that provide transportation services to the Ecuadorian expedition members. The trip began by plane from the city of Guayaquil, making a stopover in Santiago de Chile
until reaching the city of Punta Arenas. Here, the means of transport will be changed to embark on the military ship Achilles of the Chilean Navy. After 4 days of navigation, the Antarctic continent was reached where the islands were explored for 4 more days according to the ship's itinerary. In the first approach on the Pedro Vicente Maldonado Ecuadorian Scientific Station, the strong wave prevented the landing of the container from the refuge, having to continue its route to the Chilean station. On the way back, the ship would try again to make the landing, which was happily possible thanks to the fact that the wave condition allowed it. The 12 days assigned to the expedition members on their stay at the Ecuadorian station prior to the return shipment would begin. On the 12 days, 11 were dedicated to the construction of the Ecuadorian Antarctic Refuge. As in many construction processes, there are unforeseen events, and ours was no exception. The selected place known as Whale Graveyard was not suitable for construction due to the low resistance of its soil and especially the presence of lichens. Due to this, it was decided to build the project on a higher, more resistant and flat point, the sector known as the Sleeping Lion, located in Punta Orion.
Start. When the tide finally allowed the EAR container to be brought to shore, another problem arose. The base could not roll due to the weight of the container. Due to this, we had to manually remove the pieces of the shelter until the weight is optimal to roll the container onto dry land. We start with the layout and stakeout on the site, and with the material ready on the ground, we began to assemble the structures of the plinths and then cast them. Then we cast 2 braces that together with the compacted rubble would function as a base for the refuge. The next step was to assemble the metal structure made up of 2 sleds designed to move the refuge in case it is required elsewhere, and a set of metal frames. This structure bolted together is raised in red to stand out from the snow and to be seen from far distances. With the structure ready, we proceeded to place the external bamboo skin that, together with a thick internal canvas, would protect the thermal insulating panels from direct contact with the snow and from the impact of rocks that could reach it through hurricane winds. Protected from the icy winds, we continue with the placement of the 25 cm thick thermal insulating panels on the floor, walls, and ceiling. At this point, we were ready to assemble the roof structure, also protected by bamboo panels. In the event that the snow prevents access to the isolated point of the refuge, a loft allows the rapid shelter of the expedition members. Arriving at the end of this construction, it remained to place the tensile cables that would anchor the shelter to the cast plinths, avoiding their displacement with the wind. Finally, we installed the 4 solar panels that, due to the effect of reflection in the snow, would provide energy to 2 batteries for the use of electronic devices inside the refuge. Temperature outside the refuge, 11 degrees Celsius. Thermal sensation inside the refuge, 24 degrees Celsius. And this is how it went.
This project, which took 4 years of research and was finally built in 11 days on the Antarctic continent, was more than clothing and ethical duty. This building has verified the thermal insulation properties of the so-called eco materials, has resisted the inclement weather of the Antarctic continent, and has finally become a new paradigm in ecological construction. Questions for the future come to mind. Is there a possibility that the Antarctic continent becomes a true laboratory for construction materials that are resistant to inclement weather, promoting them as a sustainable response for the future of construction? It is possible that a refuge ends up becoming an identity brand that distinguishes us from the types of refuges in Antarctica?
Bamboo, present and future of construction, will provide sustainable solutions for buildings that are safer and more respectful of the environment.